Okay, let's start with some examples. We'll do 3 examples. Hopefully I will be able to finish them. Okay. So I take the function f of x equal to x on minus pi pi. This is minus pi, this is pi, and this is f of x equal to x on minus pi pi. And now the question is, find the Fourier series of f. Okay, so let's see. We have a0 is f with 1, and this is equal 1 over pi integral from minus pi to pi of x dx, but this is an odd function, so the integral from minus pi to pi of x dx equals 0. What about an? This is f cosine nx, and this is equal 1 over pi integral from minus pi to pi of x cosine nx dx. Now this is an odd function also, so this is equal to 0. So bn, this is f sine nx, and this is equal 1 over pi integral from minus pi to pi of x sine nx dx. Now this is an even function, so this is equal 2 over pi integral from 0 to pi of x sine nx dx. Not because it's also even, or here just because it's odd. It's odd and on a centered interval. If it was this integral from 0 to pi, so you might not have, so maybe it wouldn't have been 0, but it's integral from minus pi to pi. So now I have to integrate x sine nx dx, so this is odd, even. So how do I integrate x sine nx? So this is x sine nx, so this is 1, 0, and then when you integrate you get minus cosine nx over n. I'm integrating by part, okay? Minus sine nx over n squared plus minus, and this is equal 2 over pi minus x cosine nx over n between 0 and pi plus sine nx over n squared between 0 and pi, and this is equal 2 over pi. Now I replace x, you will get 2 over pi times, you have x equal pi, so pi, and they have a minus cosine n pi over n plus sine n pi is 0, sine 0 is 0. Now what is cosine n pi? Cosine n pi is equal to, notice that if n is even, like cosine 2 pi, cosine 4 pi, cosine 6 pi, this will be equal to 1. And if n is odd, this is equal to minus 1, like cosine pi, cosine 3 pi. So this is equal minus 1 power n. Cosine pi is minus 1 power n. This is something that you're gonna, is minus 1 power n. You're gonna use many times. So you get that b sub n is equal minus 2 power minus 1 power n over n. Okay, or simply 2 minus 1 power n plus 1 over n. Then the Fourier series of f at x, which is a0 over 2, which is 0, plus summation an cosine nx, an is 0, so it would be summation from n equal 1 to infinity of 2 power minus 1 power n plus 1 over n sine nx. And this is the Fourier series. I don't know even if this makes sense, yes, if this converge, but this is the Fourier series of the function x, of the function f, and here f is x. Okay, so remark, so far we don't know if the Fourier series above converge, let alone if it converges to X or not. Okay. Now another example. So this is example 2. Let's take f of x equal absolute value of x, where minus pi is smaller than x smaller than pi. So this is my function, and I calculate the Fourier series of absolute value of x. Okay. And then the question is calculate Fourier series of f at x. So again, a0 is f1, and this equal 1 over pi integral from minus pi to pi of absolute value of x dx. Again, this is an even function now, so this is 2 over pi integral from 0 to pi of absolute value of x dx. But when x is positive between 0 and pi, absolute value of x equal to x. So this is 2 over pi integral from 0 to pi of x dx equal 2 over pi times x squared over 2 between 0 and pi equal 2 over pi times pi squared over 2 equal to pi. This is a0. What about an? This is f cosine an x, and this is equal 1 over pi integral from minus pi to pi of absolute value of x cosine nx dx. Now this function is even, so this is equal 2 over pi integral from 0 to pi of absolute value of x cosine nx dx, but now x is positive, so this is equal 2 over pi integral from 0 to pi of x cosine nx dx. And this is, well, let's calculate it. Now you have x, 1, 0. You have cosine nx. The integral of cosine nx is what? Is sine nx over n. And then it's minus cosine nx over n squared. So this is plus minus. So this is equal 2 over pi times x sine nx over n between 0 and pi plus cosine nx over n squared between 0 and pi. Now at x equal pi, sine and pi is 0. At x equals 0, you have 0. So this will be equal to 2 over pi, this vanish. Cosine and pi is minus 1 power n minus 1 over n squared. Okay. Now what is minus 1 power n minus 1 over n squared? This is equal, if n is equal to 2k, which means n is even, this will be equal to 0. And this implies what? This implies that a of 2k, which means equals 0 for k equal 1, 2, this. This means the coefficient of cosine 2x is 0. The coefficient of cosine 4x is 0. The coefficient of cosine 6x is 0. Now what about if n is 2k plus 1, where k is 0, 1, 2, and here where k is 1, 2. So this means when k is 0, mean coefficient of cosine x. K is 1, the coefficient of cosine 3x. This will be minus 1 power, an odd number is minus 1, so this will be minus 2 over n squared. And this implies that a 2k plus 1 equal 2 over pi into minus 2 over n squared, but n is 2k plus 1, which means over 2k plus 1 squared. And this is equal minus 4 over pi times 2k plus 1 squared. This is the coefficient of cosine 3x, and this is important. This is k equals 0, 1, 2, and whatever. Okay. Now what about Bn? Bn, B sub n is f sine nx, and this is equal 1 over pi integral from minus pi to pi of absolute value of x sine nx dx. Now this is equal to 0. So this is equal, this is odd, sorry. So the whole thing is equal to 0. Now remember, Fourier series of f at x is equal a0 over 2 plus summation from n equal 1 to infinity of an cosine nx plus bn sine nx. Now the a0 I calculated it's pi, so this is pi over 2 plus the bn is 0. So this is n equal 1 to infinity of an cosine nx. Now the an, if n is even, which means the coefficient of cosine 2x, cosine 4x, cosine 6x, these are 0. So the only terms that survive is if n equal 2k plus 1, where k goes from 0 to infinity. So this is pi over 2 plus summation from k equals 0 to infinity of minus 4 over pi cosine. Now what is n in this case is 2k plus 1. 2k plus 1 x over 2k plus 1 squared. And this is equal pi over 2 minus 4 over pi summation from k equals 0 to infinity of cosine 2k plus 1 x over 2k plus 1 squared, and now you can reindex the k to n. And this will be the Fourier series of the function absolute value of x. Okay. One more example. Example 3. This will be our last example. What if f of x equal to 0 when minus pi smaller than x smaller than 0, and 1 when 0 smaller than x smaller than pi? So this is a function that is 0 here, this is minus pi, and then it is 1 here. Well, at 0 it doesn't really matter, okay, because when you do the integral it doesn't matter. So let's say it's this way. Okay. When you do the integral, it doesn't matter if you change only a point. Okay. And then what is a0? It is f with 1, and this is 1 over pi integral from minus pi to pi of f of x dx. But here my function is piecewise, so this is 1 over pi integral from minus pi to 0 of f of x dx plus integral from 0 to pi of f of x dx. But now from minus pi to 0 my function is 0, and here my function is 1. So this is 1 over pi integral from 0 to pi dx equal 1 over pi times pi equal to 1. Again, now what is an? An is f cosine nx, and this is equal 1 over pi integral from minus pi to pi of f of x cosine nx dx, and this is equal to 1 over pi integral, the only one that will survive, from 0 to pi cosine nx dx, because f is 0 from minus pi to 0 as above. I divided the integral, and this will be 1 over pi sine nx over n between 0 and pi, and this is equal to 0. Now by b sub n is 1 over pi is what? F sine nx, and this is equal 1 over pi integral from minus pi to pi f of x sine nx dx, and this is equal 1 over pi integral from 0 to pi of sine nx dx, equal 1 over pi minus cosine nx over n between 0 and pi, and this equal 1 over pi over n minus 1 power n plus 1, and this equal 1 minus 1 power n over n pi. Now again, a sub n is equal, if n is even, which means n equal to k equal 1 to whatever, if n is even, this is equal to 0. Now if n is to k plus 1, where k is 0, 1, whatever, this will be 2 over n pi. And this is your bn, yes? Sorry, this is my b sub n. And your n here is 2k plus 1, so I can replace n by 2k plus 1. And this implies there's a Fourier series of f at x. It is a0 over 2, which is half, plus the summation of an cosine nx, these all vanish, plus the summation bn sine nx, only the odd term survive. So this will be 2 over pi summation from n equals 0 to infinity, or from k equals 0 to infinity of sine 2k plus 1 x over 2k plus 1. And this is the Fourier series. Now notice with me the following. What is the Fourier series of f at 0? The Fourier series of f at 0 is equal to 1/2 plus 2 over pi summation from k equals 0 to infinity of sine 2k plus 1 times 0 over 2k plus 1. And this is equal to 1/2. But what is f of 0? F of 0, as I define it, is equal to 1. In fact, I can define f of 0 to be 0. I can define f of 0 to be 1. I can really define f of 0 to be 10. So whatever I define f of 0 to be, the Fourier series of f at 0 is different than f of 0. Well, except if I define f of 0 to be half. But the way I define it now, notice that the Fourier series at 0 is different than my function at 0. So, okay. So, I mean, is this, does this mean that it won't work? I mean, we see that point. But let's say, what is the Fourier series of f here at the value pi over 2? It's equal 1/2 plus 2 over pi summation from k equals 0 to infinity of sine 2k plus 1 pi over 2 times 2k plus 1. So this is equal 1/2 plus, okay, now what is sine 2k plus 1 pi over 2? This is equal sine of k pi plus pi over 2. And this is equal, if k is even, like 2, 4, it's like the sine of pi over 2, so this is equal 1 if k is even. And this is equal, if k is odd, like pi plus pi over 2, 3 pi plus pi over 2, equal to minus 1 if k is odd. So this means this is equal to minus 1 power k. So this means that the Fourier series of f at pi over 2 equal 1/2 plus 2 over pi summation from k equals 0 to infinity of minus 1 power k plus 1 over 2k plus 1. Now you know by alternating series that this converge, but to where it converge, recall that arc tangent of x, the power series is x minus x cubed over 3 plus x5 over 5 minus x7 over 7 plus plus plus. And this equals summation from n equals 0 to infinity of, well, from n equal 1 to infinity, n equals 0 to infinity, sorry, minus 1 power n, x power 2n plus 1 over 2n plus 1. Yes. So what is arctangent of 1? Arctangent of 1 is summation from n equals 0 to infinity from minus 1. Yes, this is true for x between minus 1 and 1. So this is arctangent of minus 1 power n over 2n plus 1. And this is equal to what? This is equal to arctangent of 1 is equal to pi over 4. So this implies that summation from k equals 0 to infinity of minus 1 power k plus 1 over 2k plus 1 is equal minus 1 times pi over 4. So this implies that the Fourier series of f at pi over 2 is equal to 1/2 minus 2 pi times pi over and this is, sorry, the arctangent of 1 here, if n is 0, okay, something, so arctangent of x is x minus x cubed over 3, so this is, okay, something is not right in the arctangent of x. Okay, let me check that everything is fine here. So everything is fine. This is, yes, this is minus 1 power k. Yes, I don't know why I wrote k plus 1. So this is minus 1 power k sine k pi plus 2. Okay, it's minus 1 power k. Sorry about that. So this is minus 1 power k, and this is pi over 4. So this is plus 2 pi over 4, and this is half plus half is equal to 1. So the Fourier series of f at pi over 2 is equal to 1. And what is f of pi over 2? If you go back to the definition of f, it is 0 here, 1 here. So this is pi over 2. So the value of f at pi over 2 is 1. So things went well at pi over 2, but didn't go well at 1. Okay? And this we're going to discuss this. So I don't expect the Fourier series to be always equal to my function. And like you saw an example that at 0, it's not the same, but at a point different than 0, it is the same, okay? Just few remarks before I conclude this session. The Fourier series of cosine x is what, guys? This will be equal to cosine x, because I already have my function as a linear combination of sine and cosine and x. Now, what is the Fourier series of cosine square x? This is, I always have it written in coordinate form. Yes, this is one of the coordinates. The Fourier series of cosine square x, this is equal to the Fourier series of half plus half cosine 2x, which is already written as alpha plus summation a n cosine n x plus b and so on n x. So it is equal to half plus half cosine 2x. The coordinate of 1 of the vector 1 is half. The coordinate of the vector cosine 2x is half. Okay. Notice that if the Fourier series of f at x makes sense, then the Fourier series of f plus g at x is equal to the Fourier series of f at x plus the Fourier series at g at x. This is, you have to prove it in the homework, because the a0 of f plus g is the same as a0 of f plus a0 of g, and cf at x equals c Fourier series of f at x. And notice that the Fourier series of f evaluated at x plus 2 pi is equal the same as Fourier series of f at x. It's a linear combination of 2 pi periodic functions. So it's periodic, it's 2 pi periodic. Again, if the Fourier series makes sense. I mean, if it converges to somewhere. Thank you.